this video, we'll still talk about 8.2, but this is the part 2 of it, where we will talk about more advanced calculation on Kc and Kp. So previously, you have learned on how to calculate the Kc, Kp when the concentration or the pressure of the species is given at equilibrium. So it's pretty simple. You just write the correct formula of Kc, Kp based on your chemical equation. You put in the value and you press the calculator. But what happened when the system is not at equilibrium? What happened when the value given in the question is not at equilibrium yet? How do I find the Kc, Kp? So in this video, we'll focus on solving question like this. So generally, when the system is not at equilibrium, we have 3 big steps, alright? This is not the only step, but this is the 3 big steps. The step 1 is you must have a balanced chemical equation with phases. You know how important balanced equation and phases are in Kc and Kp because the coefficient in the balanced chemical equation will become the power of the concentration or pressure, and the phases, you know that Kc will only take count of gas and aqueous, while Kp will only take count of gas. So it's very important to have a balanced chemical equation with the correct phases before you solve the question. The second step is what we are going to focus on today, is we are going to do an I.C.E table. So what is actually I.C.E table over here is your initial, your changes, and also your equilibrium. So your initial, we know that is before the experiment started, before the reaction started. Where in your initial, you will have plenty of reactant, but you will have your product 0. Okay, that is your initial. Changes, obviously, changes means how much the reactant has reduced and how much the product has increased. And last but not least, equilibrium is what we are looking for. Equilibrium is the one that you can put into your Kc or your Kp. We will focus on the step 2 more during the question, so don't worry about that. And last but not least, generally you are going to proceed by writing the Kc or Kp depends on the question, and then you are going to solve the mathematics. And the mathematics that we have today will play a lot with quadratic. Alright, we are going to play a lot with your x square and so on. So we are going to find unknown over here. Don't worry, I will guide you through with all the example that we're going to look into later on. So before I proceed to the example, we are going to focus a bit on what is actually initial change and equilibrium. I will be using symbol for the initial change and equilibrium when they are doing calculations, so I want to explain the symbol a bit. So first and foremost, if I'm having Kc, you know that it's a concentration. And you know that concentration, we'll be using a symbol of square bracket. So I'm going to use this square bracket later on a lot. So in the concentration Kc, the symbol that I will use for initial is the square bracket with a subscript I. So the I over here means is the concentration at initial. So the concentration at initial actually means what? It actually means the concentration before reaction started. So that is the value that normally your reactant will be very high and your product will be 0 because there is no product produced yet. Next, you have your change, and this is the symbol of changes that we are going to use. The triangle over here represents changes. So that is your concentration changes. And changes, like I said, is how much of the reactant has decreased and how much the product has increased. We'll focus on the changes on the next slide, don't worry. And last but not least, your I.C.E table is your initial, change, and equilibrium. So the equilibrium will be represented by the EQ, that is your equilibrium. So this is the value that you can put into your Kc. Because we have discussed in the previous video, the value that goes into Kc must be the value already at equilibrium. So this is the value that we can put into your Kc because it's the concentration at equilibrium. Okay? Next, what happens if it's a Kp? You know that Kp over here represent pressure. So pressure, the symbol that I will use is the partial pressure P. So for the initial changes and equilibrium, the symbol is the same, but we are going to change the concentration to pressure by using the P symbol. So this is again the pressure at initial, before the reaction started, and when the reactant is very high, the product is 0. That again is your changes in the term of pressure, and last but not least, that is your equilibrium in the term of pressure. So like concentration, the value that you can put into Kp will be the value at equilibrium. So we'll be using this symbol a lot, okay? Whether it's a concentration or whether it's a pressure will depends on the question. So if the question gives you the Kc, then it will be in concentration. If the question gives you in the Kp or the question gives you in pressure, then it will be in pressure. Next, we want to focus on changes. Alright, so changes is something new over here. So we are looking at changes. How do we identify the changes? So I have an equation over here. So first thing before we do it, we need to make sure that this equation is balanced. Alright, so please make sure the equation is balanced before you use it. So the equation that I have on the screen right now is balanced. Second, you need to check the phases. Alright, so the phases for concentration that we will involve or we will take count is gas and also aqueous. So you can see over here is gas, and is gas. So we will take count of everything. So next, what would be the changes? The changes over here were based on the balanced chemical equation. So I'll show you first. The changes over here for reactant is minus 2x. So let me explain why minus 2x. Minus because it's a reactant. When it's a reactant will decrease when the reaction started. That's why it's a minus. So when the reactant decrease, these changes will be decreasing. So you have a minus over here. The 2, why is that a 2? Because the coefficient of ammonia is 2. So the coefficient of ammonia is 2 over here. That's why you have a minus 2x. X is the rate. Everybody will be using x in the changes. So you have your minus 2x over here. Next will be your product. If your reactant is minus because reactant is decreased, so what do you think your product will be? Yes, your product will be positive, will be plus X for nitrogen gas and plus 3X for hydrogen gas. First and foremost, why plus? It's a plus because they are product. And we know that product will increase along the experiment. So, the changes that the nitrogen gas and hydrogen gas will experience is positive. It's plus because the product will increase. And over here, why is that 1x? Because the nitrogen is 1. Why is that 3x? Because the hydrogen, the balanced hydrogen, is 3 hydrogen gas. So you have a 3 over here. So the number that you have in front of your x will depend on the balanced chemical equation. Whether it's a positive or a negative will depend on whether it's a reactant or product. Reactant always decrease, product always increase. Okay, simple. So it's very important for you to have a balanced chemical equation. Next, we have something very similar, but now is pressure. So pressure, we know that we will take count of gas only. So make sure you check your equation and everything is in gas only. Or I would say, it's not necessary everything to be in gas, but we will only take count of the gas. So the changes that the partial pressure of CO2 is minus X, CF4 is minus X, over here is plus 2X. That is the changes that you can identify from the balanced chemical equation. Again, it's a minus because they are reactant. Reactant will decrease along the experiment. It's a 1, 1, so it's minus x. Over here, because it's a product, since product will increase along the experiment, that's why you have a positive. It's a 2x because you have a stoichiometry of 2. Simple. That is the way that we identify the changes from balanced chemical equation. So if you are ready, we shall go into your examples. The first example that I have on the screen over here is with this equation, the decomposition of ammonia over here. So the question stated, a student started means what? Started means initial. Started an experiment by decomposing 0.032 molar of ammonia to form nitrogen gas and hydrogen gas. At equilibrium means what? It's already achieved equilibrium. So at equilibrium, the concentration of N2 obtained is 0.08 molar. I have two values over here and I have two conditions. The first condition is the started. Started over here means initial. At equilibrium over here means at equilibrium where the system already attained equilibrium. So over here, 0.032 molar is at initial. So I can take it out first. That is the concentration of ammonia at initial, which is 0.032 molar. And then I have concentration of N2 at equilibrium, which is 0.008 molar. Take it out first. Next, the question asking for Kc is how much? That is what the question asking for. So as always, read the question very carefully. Identify whether the value right now is initial or equilibrium. Take it out and label them correctly. So make sure you read the question very carefully and make sure you know exactly the value is at initial or at equilibrium. Next, we are going to answer the question. Starting with the step 1, the balanced chemical equation. So you already have the balanced equation over here with the correct phases. Therefore, we can move to the second step, which is your I.C.E. table. So to start off your I.C.E. table, make sure you copy back the balanced chemical equation correctly. We will start off with the balanced chemical equation. 2 mole of ammonia in gas, reversible arrow, 1 mole of nitrogen gas, and 3 mole of hydrogen gas. Make sure you copy them correctly. Start off with the concentration initial. So the concentration initial of ammonia, 0.032 molar. Concentration initial of the product nitrogen and hydrogen will be 0, 0 because there is no product formed yet. Next, concentration changes. The concentration changes over here will be minus 2x. We know that y is a minus 2x. And then plus x for the product and plus 3x for the hydrogen. Positive, plus because they are product, negative because it's a reactant. The 2, 1 and 3 will depend on the stoichiometry of your balance equation. Last but not least, your equilibrium over here. What would be your equilibrium? Simple. Initial minus changes. So initial 0.032 minus 2x will be my equilibrium. Over here, 0 plus x. So x will be my equilibrium. 0 plus 3x. 3x will be my equilibrium. Can you see over there? You're moving from your initial, go down to your changes, go down to your equilibrium. Okay? So that is your complete I.C.E. table. So from this I.C.E. table, how can we proceed? Pretty simple, because the nitrogen equilibrium is given. So the nitrogen equilibrium is 0.08. Equilibrium concentration for nitrogen is X. So in the other words, the concentration of nitrogen at equilibrium is equals to X over here. and the nitrogen equilibrium given in the question is 0.008 molar. Therefore, we know that X right now equals to 0.008 molar. So when X equals to 0.008 molar, you can solve the rest of the X. You substitute in 0.08 into the X. So over here will be 3 times 0.008, which is 0.024. And over here is your 0.032 minus 2x 0.008. Press your calculator, you realize that is 0.016. So at this moment, your equilibrium concentration for ammonia is 0.016. For nitrogen gas, 0.08 given. For hydrogen gas, 0.024 calculated. But question asking for Kc. So what would be the Kc? Write the formula. Kc over here equals to product versus reactant. So my product, nitrogen, hydrogen. Product, nitrogen to the power of 1 because the ratio is 1. Hydrogen gas to the power of 3 because the coefficient is 3. Over concentration of ammonia to the power of 2 because the coefficient is 2. Substitute in the value that you have calculated just now at the equilibrium. So at equilibrium for nitrogen gas, 0.008. For hydrogen gas, 0.024 to the power of 3. Don't forget the power. Over 0.016 to the power of 2. So again, don't forget the power. And last but not least, pick up your calculator right now and press it. Solve the mathematics. Be very careful with the power 3 and be very careful with the power 2. Make sure you use your bracket in your calculation. And the answer will be 4.32 times 10 to the power of negative 4. That is the Kc calculated for this question. Simple. So I hope you can do the I.C.E table. I hope you understand what is the I.C.E table about over here. What is the initial, what is the changes, and how do we get the equilibrium. Bear that in mind, the value that you put into your Kc must be all the value at equilibrium. Okay? I hope you're doing it together with me. You won't understand if you're just looking at the calculation. You will only understand if you are doing the calculation. Okay? Next example that I have, example 2. So I have N2O4 gas to become 2NO2 gas. So everything is in gas over here. The question stated the equilibrium constant Kp. So Kp given 3.65 atm. So question give you the Kp 3.65 atm negative 1. At 380 Kelvin, calculate the partial pressure at equilibrium for all species if 0.75 atm of N2O4 is placed to initiate the reaction. So as always, we need to identify the value given is what. So the first value given, 3.65, is the Kp. The second value given, 0.75 atm given, is placed to initiate the reaction. Initiate over here means what? Means that is your initial, alright, your beginning. So take out all the value. Kp given 3.65. Partial pressure initial of N2O4 given is 0.75 atm. So what the question asking for? The question asking for the partial pressure equilibrium of N2O4 and also the partial pressure at equilibrium for NO2 is how much. That is what the question asking for. So the first step, as always, we'll start off with the balanced chemical equation and the phases. So we are talking about pressure and we only take count of gas and gas. So both are gas, we'll take done. And the equation is balanced, so we are done for the step 1. For the second step, we are going to do the I.C.E table. And we always start your I.C.E table with your equation. So my equation over here, N2O4 gas produce 2 NO2 gas. That is my equation. Start off with the partial pressure initial. Partial pressure initial of N2O4 is given 0.75. Put it in, and the product will be definitely 0. As always, product at the beginning is 0. So the partial pressure change over here will be minus X. Because it's a reactant, it will decrease along the experiment. Over here, plus 2X. It's a plus because it's a product where the partial pressure will increase along the experiment. And it's a 2X because the coefficient is 2. So that is your changes. And then you have your partial pressure equilibrium. Partial pressure equilibrium, 0.75 minus X. Over here, 0 plus 2X, so 2X. And that is your complete ice table. So how can I proceed? I'm looking for the partial pressure at equilibrium for N2O4 and NO2. So we are looking for 0.75 minus X and 2X. So what is the X? How can we get the X? Simple, use the Kp. So write the Kp formula. My Kp over here is the partial pressure of product versus reactant. So I have my product partial pressure of NO2 to the power of 2 because the coefficient is 2 over the reactant coefficient is 1. So partial pressure of N2O4 to the power of 1. So that is the Kp formula that you will get 1 mark for. And that is the simplest thing ever, as long as your equation is balanced. Next, put in the value of Kp. So you have the Kp value 3.65. Put in the value of the partial pressure of NO2. NO2 over here, 2x square. Put in the 2x. Over 0.75 minus x. So you have 0.75 minus x. I hope you can see the quadratic by now. So what are you going to do is you're going to solve this mathematics using the quadratic concept. First and foremost, you're going to times this, alright? And you're going to open up this, okay? So you're going to solve everything and make it in the form of quadratic equals to 0. So you will have 4x squared minus 3.65x minus 2.7375 equals to 0. And what are you going to do next? Simple. Put everything into your calculator, choose the equation with degree 2, put your A, put your B, put your C. So make sure you put in together with your symbol minus. When you put everything in your calculator, you will have your x1 and x2. So your x1 from the calculator should be 0.4885 and your x2 should be negative 1.401. So you have two value of x over here. Which one are we going to take? If the two value, one is positive, one is negative, easiest ever because we will take the positive. We will ignore the negative because it's a negative. We cannot use the negative. Alright, negative means is there any changes or is there is no changes. So we cannot take the x when it's negative. We will ignore it. Therefore, we will take the x over here is 0.4885. So when you found your x already, what do? You put into your ice table again. So you have your ice table over here, 0.75 minus 0.4885. So you have your partial pressure equilibrium of N2O4 calculated will be 0.2615 atm. And over here you have 2x, so it will be 2 times 0.4885 and you will have 0.977 atm. And this is the partial pressure at equilibrium for N2O4, 0.2615. For NO2 is 0.977 atm. Simple. Everything is quite simple except your quadratic. I know some of you might struggle with your quadratic, so make sure you can solve your quadratic over here. Make sure you put everything into your calculator correctly. Alright? And when you have two values of x, we always ignore the negative. We always ignore the negative. We will only take the positive. Okay? So, your third example over here, you have your balance equation 2COF2 gas, CO2 gas, and CF4 gas. So, everything is gas. That is pretty simple. We are going to use everything, no matter question asking for KC or KP, because all of them are gas. So, in the question, as the system achieves equilibrium, the partial pressure of CO2 and CF4 at equilibrium is the same, 1.15 atm. So, your 1.15 atm is at equilibrium. Straightforward. Determine the partial pressure of COF2 before the reaction started. If the Kp of the above is 1.85. So the previous two examples that we have discussed is the question gives you the initial. But in this question, the question asks you to determine the initial partial pressure of COF2. So we need to determine the pressure of COF2 before the reaction started. That means initial. So you have your initial change equilibrium. Previously, we give you the initial, you identify the change, you get the equilibrium. Right now, the other way around. So we give you the equilibrium. The equilibrium of CO2 and CF4 is given 1.15. We give you the equilibrium, you need to identify the changes and find the initial. So we are moving backward right now. Let's see how we are going to solve it. As always, take out the value first. So the value that the question gives to you is the partial pressure equilibrium of CO2, which is 1.15. The partial pressure equilibrium of CF4, also 1.15. The question gives you Kp, 1.85. And the question asking for partial pressure initial of COF2 is how much? So that is roughly the question. Take out the value, it will make your life much easier. Okay, don't read the question 1,000 times. We already have the balance equation, so as always, the second step is your I.C.E table. Your I.C.E table with the balance equation. So I have the balance equation over here, 2COF2 gas produce 1 mole of CO2 gas produce 1 mole of CF4 gas. That is my balance equation. So, pressure initial. This is the unknown that we are looking for. Put your unknown with something. Let's say Y. This is the Y that we are looking for. So, your CO2 initial will be 0. Your CF4 initial will be 0 because they are product. The partial pressure change, as always, we have learned previously. That is your reactant, so it's a minus 2x. Over here is your product, so plus x, 1, because the ratio is 1, plus x, because the ratio is 1, and they are product. And then your partial pressure equilibrium over here will be your initial y minus 2x. Initial 0 plus x, initial 0 plus x. Okay? You can see above, in the question, the partial pressure equilibrium of CO2 is given 1.15. Partial pressure of CF4 is given 1.15. The partial pressure of CO2 is x. Partial pressure of CF4 is x. That's why they are the same. In the other words, we know that right now, x is equals to 1.15. So we know that x right now is equals to 1.15. Okay, so you can put in over here y minus 2x 1.15. So it's y minus 2.30. So that is your equilibrium at this moment. But the question is asking for y. This is your y, partial pressure initial of COF2. We are looking for the y. So how can I solve it? Simple, using the Kp formula. So started by writing your Kp formula. Kp equals to your product versus your reactant. The product over here, partial pressure of CO2 to the power of 1 because the ratio is 1 times partial pressure of CF4 to the power of 1 also over the partial pressure of COF2 to the power of 2. So substitute everything in. Your Kp is given 1.85. So 1.85 is the Kp. Partial pressure of CO2 is 1.15. 1.15 for both products. Over, you have over here is y minus 2.3 square. Can you see your quadratic again? So make sure you solve this quadratic according to your mathematics rules. You expand your y minus 2.3 square and then you solve the 1.15 times 1.15. Solve your quadratic, make sure it's back to 0. So after you solve it, you should be able to get 1.85 y square minus 8.51y plus 8.464 equals to 0. So press your calculator into the equation of degree 2. You will be able to find your y1 and y2. And your y1 over here is 3.1455 and your y2 calculated 1.4545. So both are positive value. Just now we have one positive and one negative, so we choose the positive. But what happens when both are positive? We will look at the changes. Y is the initial that we are looking for. Alright? The changes over here is 2x. So we calculate the 2x for a bit. So the partial pressure changes of COF2 is 2x. So we know that x equals to 1.15. So 2 times 1.15 will then give rise to 2.3. So if the changes right now is 2.3, what do you think the initial will be? The things that you put in, alright, for the reaction cannot be less than what you need. Make sense? Alright, your initial should always be bigger than your changes. So 3.1455 and 1.4545, which one will be ignored? This one will be ignored. Alright, why this one will be ignored and this is accepted? Because the changes is 2.3 and the initial must be bigger than the changes. Okay, makes sense? So your y cannot be 1.4545. Therefore, y over here is 3.1455 and that will be the initial pressure of COF2 calculated. So the initial pressure of COF2 calculated will be 3.1455 atm. That is the partial pressure initial of COF2. Make sense? Okay. So it's pretty simple over here if you get it. If you have the y1 and y2, we will always ignore the negative if there is one positive and one negative. But what happens when is both positive? We will always choose the value that makes sense. We will always choose the value that is logic. And there is only one way to compare. Look at the changes. Alright, simple. If you have both positive value calculated, look at the changes. From the changes, identify which value is logic, which value makes sense. Okay? Next example that we have, and the last example for this video, example 4, SO2 gas, Cl2 gas, and SO2Cl2 gas. So again, everything is gas over here. I'll give you a very simple example, because gas involved in your Kc or Kp, so it doesn't matter. The experiment above is carried out at 450 Kelvin in a 2-liter flask by using 0.345 mole of SO2 and 0.5 mole of Cl2. The Kc given for the reaction above is 12.45. Calculate the concentration of SO2Cl2 at equilibrium. So we are looking for the concentration of SO2Cl2 at equilibrium. So as always, identify the value first. The temperature is 450 Kelvin. The volume given 2 liter. Why the question gives you volume? Because they're giving you number of mole. So if you read the question, if you read the first sentence over here, experiment above is carried out at 450 Kelvin, 2 liter flask by using 0.345 and 0.5 mole. Is carried out means you started the experiment with that much. In the other words, that is your initial. That is your initial. So the main thing over here is when you read the question, you need to be able to identify the value given right now is initial or equilibrium. Read the question carefully, okay? The Kc given 12.45. So as always, take out all the value. Number of mole initial of SO2 given 0.345. Number of mole initial of Cl2 is 0.5 mole. So the volume given over here is 2 liter. And the question also gives you the Kc. Kc given 12.45. And last but not least, question asking for what? Question asking for concentration of SO2Cl2 at equilibrium is how much? That is the entire question. Okay? So what do we do when you have the number of mole and the volume? Question gives you Kc. Obviously, you need concentration. So the number of mole initial, to change to concentration initial, you will take the number of mole and divide by the volume. 0.345 divide 2.0 liter. And the concentration of SO2 initial calculated is 0.1725 molar. And over here, concentration of Cl2 initial will be 0.5 mole over 2 liter flask. So it will be 0.25 molar. So you have the concentration initial, you have the equation, question asking for the equilibrium. We start off with I.C.E. table. So your I.C.E. table over here, make sure you always start your I.C.E. table with your balance equation. SO2 gas plus Cl2 gas forming SO2Cl2 gas, 1:1 ratio. So you have your concentration initial over here. The concentration initial of SO2, you just calculate it, 0.1725. Cl2, 0.25. And the product, 0, as always. The concentration changes over here, minus X, because it's a reactant with stoichiometry 1. Minus X, again, is the reactant with 1 coefficient. And over here as your product, plus X. The plus over here because your product increased along the experiment. And your equilibrium over here, obviously, simple, straightforward, 0.1725 minus X for the SO2. Cl2, 0.25 minus X. And last but not least, X for the SO2Cl2. And the question asking for the concentration of SO2Cl2 at equilibrium, in the other words, what are we looking for? We are looking for this, concentration of SO2Cl2 at equilibrium. In the other words, you are looking for the X. So how do we find the X? As always, Kp or Kc. So the question over here is Kc. Write the formula of Kc. You have your Kc equals to product versus reactant. Product over here, SO2Cl2 to the power of 1 over your reactant, SO2 to the power of 1 because its stoichiometry is 1, and the Cl2 to the power of 1. Okay, can you see the quadratic? It's the same thing, guys. It's the same thing. So the Kc given 12.45. The concentration of SO2Cl2, X. The concentration of SO2, 0.1725 minus X, times 0.25 minus X, the concentration of Cl2. So that is your quadratic again. So we are playing with a lot of quadratic. It It's actually not chemistry over here. It's actually a lot of mathematics, okay? So make sure you can solve your quadratic over here. And the quadratic that you will be obtained from this KC is 12.45 x squared minus 6.260x plus 0.5369 equals to 0. That is the quadratic. And as always, your calculator, press the mode, press the equation, choose for the degree 2, put in everything. Make sure you don't miss out the minus and the plus over here when you key in your value into your A, B, and C. And you're going to find 2x. So again, you have your x1, again you have your x2. So your x1 and your x2 over here will be 1. Are they positive, negative, or are they both positive? If I'm not mistaken, your x1 calculated should be 0.3931. Your x2 calculated 0.1097. So again, you have two value positive. So when you have two value positive, what are we looking at? We will focus on the changes, alright? Look at your reactant. You have two reactant over here. SO2, Cl2. Choose the one with a smallest concentration initial. So the concentration smallest initial is 0.1725 of SO2. The changes is minus x. So if your initial is 0.1725 only, the question only gives you that much, and the changes is minus x. And over here, your x, what do you think your x will be? 0.3931 or 0.1097? Your initial is only 0.17, and we know that the changes must always be smaller than the initial. So the minus x will be the smaller value over here. So the smaller value over here, 0.1097. Okay, that is the smaller value compared to your initial in your SO2. Your initial is 0.1725. So if your changes is 0.1097, that is makes sense. Over here, this will be ignore. This will be ignore, and we are not going to look at it. Why? Because it's bigger than your initial. It doesn't make sense anymore, right? So your x2 over here is 0.1097, and if you look at it, if that is the x that you accept, we are looking for the equilibrium of SO2Cl2, which is now x. In the other words, the concentration of SO2Cl2 at equilibrium is equals to x. Therefore, is equals to 0.1097 molar. X over here equals to 0.1097 molar. And that is the concentration of SO2Cl2 at equilibrium. And that's it. Alright, I know that my example are not those easy example, because if it's easy, you can do it on your own. So if you can understand all my example, you should be good enough to go for other questions. Okay? Again, the part that you might struggle is actually your quadratic. The rest should be simple. So make sure your mathematics is good enough to expand the bracket, to expand your quadratic equation. And make sure you press your calculator correctly. Okay? And the most important thing, actually, the value given in the question is actually initial or equilibrium. When you read the question, make sure you can identify the value given right now is initial or is equilibrium. Okay? That is one of the most important thing. And second thing, your balance equation. Very, very important to have the balance equation. If you can see over here just now, when we are doing all the example, your I.C.E table will be 100% depends on the balance equation with the correct phases. Okay? And last but not least, your I.C.E table. So, initial, changes, and equilibrium. That is your I.C.E table. Okay? Initial, changes, and equilibrium. So make sure you can do your I.C.E table correctly. Make sure you know that what is your initial value, how to identify the changes based on the balanced chemical equation. Alright, how to get the equilibrium. Equilibrium is always initial minus changes. That is your equilibrium. Okay? Make sure you can write your Kc and Kp correctly at the end of it. Is the quadratic. Okay? Make sure you can do your quadratic equation. Make sure you can solve your quadratic equation. And last but not least, when you have your x value, you have your x1 and you have your x2 value, make sure you choose them correctly. Which one are you going to choose? This selection of x1 and x2 will depend on the changes. Okay, look at the changes and the initial. Look at the changes and the initial, because that will determine what is your x1 and x2 or your unknown. Okay, bear that in mind, your initial must always bigger than your changes. Vice versa, your changes must always smaller than your initial. Okay, and that's it for this video, and I hope you understand the calculation. And if you do give me a like for this video, and don't forget to subscribe to my channel. I'll see you in the next video. Thank you for watching.